You now have one half of the skeleton built and positioned, but we aren't ready to skin the models just yet. In this video, we're going to make sure the rotational axes and rotate orders are all set up. Once they are, we can then safely move on and look at making this skeleton drive the creature model. First, I wanted to tell you about a few updates I did to the skeleton since the last video. I added another twist joint here where the hand joint is. This will help us to get a nicer rotation in the wrist. I also did the same with the foot, adding another twist joint here. If you're not completely sure how the hierarchy has changed, please take a look at the source files. Okay, so that's updated. Let's see how the rotational axes are looking. Let's select the root joint and go to Select Hierarchy. Now go to Display, Transform Display, Local Rotational Axes. I can already see a lot of these are looking okay. This is because we specified that we wanted Y to point down the joint in the joint creation options. The problem is we've been moving these around, so even though some of these look fine, they may actually be slightly misaligned. Or, like here, more obviously broken. It's not a problem though, because we can easily fix them with the Joint Orient tool. So the root is fine, we need this to stay matching the world orientation. The same with the cog. So let's select the pelvis joint as the starting point. And go to Skeleton, Orient Joint and open the options. Let's reset the settings. So we want Y to be the primary axis. And we want the secondary axis, which is Z, to point forwards along the world's Z axis. Okay, that's set. If I apply that now, you will see the spine is fixed. And this update will also travel through the upper body, setting the rest of the joints for us. So this will fix those small issues. With the head, we ideally want this to be reset back to the world orientation too. It makes it better for the animator and the controls this way. If I set this to Orient Joint to World and apply it, you will see that this isn't how we want it to be orientated. It's inheriting the orientation from its parent joint, but we want it to match the world axis. So all we need to do is temporarily unparent it from the neck joint. If we try that again, it now works because its parent is the world, so it's matching that orientation. It's also updated the eye joint for us too, which is good because this is how we wanted this orientated too. Okay, let's parent the head back to the neck. So the head works well, and so does the eye. Good. Okay, let's check the arm. Clavicle looks good. So does the upper arm. And the lower arm. The fingers actually look okay too. The wrist does have some issues though. There are mixed orientations here where the Orient Joint tool has got a little confused. We can fix this in much the same way as we approach the head. Let's unparent the fingers and thumb. And select the hand joint and the twist joint too. All we need to do is reset those. Now the orientation matches the upper arm and elbow, which is exactly what we need the wrist to do, so it moves correctly. We can now parent the fingers back to the hand joint. Okay, let's update the leg next. Select the thigh joint this time. And turn off Orient Joint to World. So these are set the same as the upper body. And let's apply that. I saw a few orientations update then. Looks like the toes and the foot are a bit of a mess though, so let's fix them. Just like with the hand, we need to unparent the toes first. And we could reset the foot joints now. Now this looks okay, but when it comes to the foot, we need the orientations to be a little different. At the moment, they are just inheriting the orientation from their parent joints. Let's unparent these temporarily and reset them again, but this time make them match the world orientation. You see, we want the animator to have the ability to position the feet using this orientation instead, which makes animating things like walk cycles so much easier. It also helps in the game engine too with foot placement. Okay, let's parent the foot joint back to the calf joint. We can parent the toes back to the foot joint too. So if we apply the same orientation to the toes, they look wrong. Y is fine because it's pointing to the next joint, but the X and Z axes are all over the place. This is because the Y axis is pointing forwards, so the Z axis doesn't know where to go. So with the toes, we need to change the configuration. This time we could set the X axis to always point to the side, or simply tell the Z axis to point up along the world's Y axis. Let's do that. That's much better and much cleaner. Right, now the other toe. All we need to do now is reset the end joints. Okay, good. The foot is looking much better now. One thing we also need to check is that the rotation attributes are all at 0. Having values on these will cause problems, not only with the rig, but with exporting animation too, so it's a good idea to make sure they are frozen. Let's quickly do that now. Select the root joint and go to Modify, Freeze Transformations and open the options. We only want to affect the rotate attributes. Let's apply that, and it will work its way through the skeleton, cleaning the rest of the joints in the hierarchy for us. Okay, so we have a bit more work to do on the hand. If we select the fingers and rotate around the Z axis, they curl, as you would expect. If we do the same with the thumb now, you will see that it bends the wrong way. We need it to curl in towards the palm when the Z axis is animated, so it matches the fingers. Again, this means the animator can simply select the controls and make a fist using just one attribute. So we need to change the thumb orientations. Select the thumb one joint, press the Select by Component Type button. Now right-click on the question mark icon and select Local Rotational Axes. We can now select the axes and edit them manually. I'll leave the end one as it looks like we need to reset it anyway. Let's rotate this so the Z axis points more towards the back. A little bit more maybe. Okay, let's go back to object mode. So now we've changed the orientations manually, we have an issue. The translate axis isn't orientated the same way. So this needs addressing. We can simply use the bit of meld script that I showed you earlier on in the workshop in the joint fundamentals video. All we need is joint -e minus ZSO. So select this and run it on the selected joints. There, the transform axis snapped to match the rotational axis. Let's update the other joints. So what we're doing is essentially baking this value onto the joint, so it zeroes it out and corrects the other axes. We don't want any values here because it will cause offset issues in the game engine and also affect the rig controls. If we select all the fingers and thumb joints now, we can rotate around the Z axis and they curl correctly into the palm. All we need to do now is reset those end joints. Okay, good. That's the orientations done, so let's create the opposite side now. Now don't worry, we don't have to go through all that again. Maya has a handy tool which will copy one side of the skeleton over to the other side for us. Go to Skeleton, Mirror Joints and open the options. If we select the clavicle, you can see we added _L to the end of its name, so we know this is on the left side of the skeleton. What we can do with the Mirror Joints tool is tell it to also rename the joints it creates for us. So here we have Search For set to _L and Replace With set to _R. Mirror Across tells Maya which plane to work with, so here it's set to YZ, so it's going to mirror across the X axis. You need to imagine the Y and Z axes are forming a wall, so the reflection will be on the opposite side of that wall. We also want the mirror function set to behaviour, but we will look more into that option shortly. If we apply that now, you see we have the right arm. If I select the arms and rotate them, you will see that the arm's movement is mirrored too. So when the left arm flaps, the right arm flaps too. This is a much better setup for the animator because it means both sides animate the same way. It also means you can copy animation from one side to the other. Let's undo that and see what happens if we choose orientation instead. Now the arms are moving the same way, which can be good in some instances, but for the animators it would mean more work. Let's add the arm back, and we will do the same with the leg. You will also see that the joint names have been updated too, so they have _R on the end. There's one more joint we need to mirror, and that's the eye. We don't need to use the mirror joint tool though, simply because we want to maintain the same orientation. If we do use it, you see, the orientation is flipped, whereas ideally we want both eyes to work the same way. Okay, let's undo that. And just duplicate this eye. Because a joint's translate values are based on its distance from its parent, we can simply invert the translate X value to move the eye across. This will place it in exactly the right place. If I set this to just be a minus number, the eye moves across and maintains the same orientation. All we need to do now is update the name. Okay, that's the orientations updated. So let's hide the rotational axes now. Select the hierarchy first. Now go to Display, Transform Display, Local Rotational Axes. There we go. Our base skeleton is looking much better now, and each joint will also rotate correctly too. Before we move on, there is another important step to take. Select the root joint and go to Skeleton, Set Preferred Angle. You can also access this through the marking menu if you right-click on a joint. This will set the preferred angle for the current joint and all its children, so selecting the root means it's applied to the whole skeleton. So why is this important? Well, it's mainly used to help dictate how your joints will bend when you add IK later in the workshop. You see, because we added a slight bend into the elbow, Maya now knows that this is the preferred way this joint should bend. If you don't use Set Preferred Angle, you might find that once you add IK and also a pole vector, the elbow bends in completely the wrong way. It also helps with the legs too. So it seems like a small thing, but it's important and will save headaches later on. Okay, the last area we want to check on the skeleton involves how each axis moves around its joint. We need to be aware of this to help reduce the chances of gimbal lock, something I covered in the earlier joint fundamentals video. To quickly recap, if I rotate a joint using the default manipulator, each axis moves with it. But this isn't really what's happening under the hood. Let's swap to gimbal instead, which is a true representation of what the rotational axes are doing. To do this, just hold Shift and Control and then click with your right mouse button to bring up the marking menu. Now just go to gimbal. We are now restricted, so we can only rotate if we select an axis. What you will see is that if we rotate Z, everything follows, but rotating X leaves Y and Z behind. What's worse is if I then rotate Y, X moves, but it clashes with Z. And this is gimbal lock. So what we need to do is adjust the rotate order attribute on each joint to minimize the chances of this happening. I say minimize because you can never get to a situation where you can completely avoid gimbal lock. We do have plenty of options to play with though. The first thing we need to know is how our joint orientations are set up. We built the skeleton using Y pointing down the joint instead of the default option, which is X. So we need the rotate order to reflect this and have Y to be more independent, so the joint can twist no matter where the arm is pointing. As mentioned previously, the rotate order uses the selected attribute to dictate the order in which each axis will affect the others. So with the default order of X, Y, Z, you have to read it backwards. So Z has full priority and will move Y and X. Y then moves X, and X is left on its own. So with our joint having Y as its primary axis, we should look for a rotate order where Y has the lowest priority. YXZ should work. Now we can rotate Y freely. If we adjust X, Y follows, so the arm will still twist correctly. The same if we rotate Z. This works better too because the arm will be rotated using Z initially to lower it, so it makes sense that the other axes follow it. Yes, we do still get gimbal lock here, but it's a bit of a trade-off. You're looking for the best possible solution for that particular area of the skeleton. So now we have a rotate order which works better than XYZ. We need to apply it to the rest of the skeleton. Now you could go through each joint and set the rotate order manually, but I have a much quicker way of doing it. I'll just open the script editor. If I move these over, and I'll just change the rotate order attribute, and then change it back. What you can see now is that Maya has given us the code we need to do this using MEL. The 4 represents the number of the item in the drop-down box. 0, 1, 2, 3, 4. They always start with 0, not 1. If I copied this now and ran it, it would set the rotate order for me on the lower arm joint. So we need to turn this into something which will work on every joint in the skeleton, which is where this little piece of MEL script comes in. Let's select the root joint, which is the first in the hierarchy. First we need to find a list of all this joint's children. We can do this using the list relatives command. The type flag with the minus next to it tells Maya we just want to look for joints. The -AD flag will search through all descendants, so everything in the hierarchy. If I select just that and run it, we get a list of all the joints. What we can do is store that list in a variable, like this one which we call joint list. It can be any name you like, it's just something to store that list. Now we have a list of the joints stored, we can use a for loop to go through each joint in the list in turn. So, for joint in joint list, joints will represent each item in the list. We can then run the code to change the rotate order, but we need to replace the name of the joint with the current joint in the list, or it's just going to be repeatedly updating that one joint. So, what we can do is use the joint variable and add the attribute to the end. And then set it to 4, which is YXZ. If I select that now and run it, it will update all the joints in the hierarchy. So that's just a tiny bit of Mel scripting. If you do want to learn more about scripting, you should check out my Introduction to Python series over on my YouTube channel. Okay, let's check this. Yep, YXZ. Okay, good, that's the skeleton updated. Now this is good for most of the joints, but there are some which would benefit from a different rotate order. Take the elbow for instance. The primary movement for this would be around the x-axis, so it doesn't need to twist, not unless this was a flexible cartoon style rig anyway. Even then, x would still be the main rotation. So here, YXZ isn't the best solution. We need to swap the order so x has the highest priority, so the other axes follow it. Let's try YZX. That's better. Everything follows now as the elbow bends. Let's update the opposite elbow now. And we can apply the same to the knees. Yep, all four of them. Okay, those are updated and working better. Next, let's look at the twist joints. So these will only ever rotate around the y-axis, in this rig anyway. Once you start introducing ribbons and other deformers, they will use others, but all that's for a future tutorial. So because Y now has priority, we ideally want the other axes to follow it. We need a rotate order with Y at the end. ZXY should do. Now as the joint twists, the others follow. Perfect. Okay, now to update the other twist joints. Don't change the shoulder or the hip ones though. These need to move in all directions. Okay, what's next? Ah yes, the head. We can revert this back to the default of XYZ because the orientation matches the world axis. And we can do the same with the eyes too. What else? Let's check the feet. We can probably change these rotate orders. We ideally want the foot twist to affect the other axes, so let's try ZXY. That should work. Okay, let's update the other joints too. We need to also change the twist too. The only other place we could look at would be the cog joint, but this moves in all directions, so we can probably leave it as it is. Like I mentioned in the earlier video, it's worth spending time experimenting with the rotation orders to get the best solution for your rig. Doing this can also help reduce the risk of joints flipping or behaving in an unpredictable way, so it's not something you want to skip. It's also important to make sure your controls and any offset groups also have the same rotate orders as the joints they are controlling, or you will end up with rotation conflicts, but we will cover this in a later video. Okay, so that's the skeleton done. In the next video we will look at binding the skin, which will attach the models to the skeleton and allow it to deform.